In 12 and 13, part A says write a negation for the given statement, and part B says use a counterexample to disprove the given statement. Explain how the counterexample actually shows that the given statement is false. For every integer n, if n is odd, then n minus 1 over 2 is odd. So the first thing we're going to do is we're going to negate this statement. Since this statement is universally quantified by saying for every integer n, that means the negation is going to start with an existential quantifier. There is an integer n, such that, and now we have to negate the implication. If this is a if p then q, the negation of if p then q is p and not q. So such that n is odd, and the negation of the conclusion, which is that n minus 1 over 2 is not odd. For part B, we have to identify a counterexample. So a counterexample is one specific instance n that makes this implication false. So we need an integer n that is odd, such that n minus 1 over 2 is not odd. Well, let's try some things. Let's try n equals 3. This satisfies the hypothesis since n is odd, since 3 is odd. But 3 minus 1 over 2 is 1, which is odd. So n equals 3 satisfies the premise and the conclusion, so it is not a counterexample. Well, let's just try a different odd number. Let's try 5. 5 minus 1 over 2 is 2, which is even. And so that means n equals 5 is a counterexample to this implication. Since 5 is odd, but 5 minus 1 over 2 is not odd. And therefore, n equals 5 is a counterexample. Thanks, everyone, and I'll see you in the next video.